Hi everyone, this is your math guru. In this video, I'm going to solve the following examples under the circle theorem that states that the line drawn from the center of a circle, if perpendicular to the chord, bisects the chord. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, I have calculate the value of S if O is the center of the circle. If you look at the chord PT, it's been stated in the diagram that the line PR, which is 30 millimeters, is equal to the line RT. Going by the circle theorem that states that the line drawn from the center of the circle, perpendicular to the chord, bisects the chord, because PR and RT are equal, that means the line OQ has bisected the chord. Therefore, the angle at R here is going to be 90 degrees. Let the distance OR equals to X such that the line OQ, as shown, and the line OP are the radius of the circle. That is, the line OP is equal to the line OQ. That's the radii. Therefore, the line OP is S is equal to the line OR or OQ. I'm going to correct that. That's line OQ. That 20 plus X. So therefore, if I use the triangle OPR, I'm going to draw a rough sketch. There's a right angle triangle. This is my P. I have the long side, the hypotenuse, S, X, and the distance PR to be 30 millimeters. Using the Pythagoras theorem, this is my R, this is my Y, and this is my X, such that R squared equals X squared plus Y squared. I'm going to substitute all the values. R squared, which is also my S, and has been shown as 20 plus X, I'm going to put that in a bracket, equals X squared, which is 30 millimeters squared, plus Y squared, Y is my X squared. Expanding the bracket, using the FOIL method, I have 400 plus 20x plus 20x plus X squared equals 900 plus X squared. Using the balance method, I'm going to collect like terms. I start by subtracting X squared from both sides. 20x plus 20x, that will give me 40x. Then I'm also going to subtract 400 from both sides, such that my new equation becomes 400 minus 400, that cancels out. I have 40x equals 900 minus 400, that's 500. X squared minus X squared cancels out. Dividing both sides by 40. Remember, whatever you do on your left, you do on your right. That's the balance method. 40 in 40, that's 1. I have X equals 500 divided by 40. I have 12.5 millimeters. Remember, the question says find the value of S, and S has been shown to be 20 plus X. Therefore, S equals 20 plus 12.5. Therefore, the value of S, which is also my radius, equals 32.5 millimeters. Always remember to include your SI unit. Let's look at the other example. In the second example, I have calculated the value of R if the radius of the circle is 5 centimeters. We've not been given the center of the circle, so I'm going to construct my own center to be O, such that the distance O to any part of the circle, which is the radius, is given. Now, the law states, or the theorem states that the line drawn from the center of a circle perpendicular to the chord bisects the chord. So if this line is assumed to bisect the chord, therefore the angle formed will be 90 degrees. And also the line is going to bisect the chord, meaning if JK is 6 centimeters, then the distance, I'm going to tag this point A and this point B. The distance AK will be 3 centimeters, and the distance BM, that's 8 divided by 2, that will be 4 centimeters. I'm going to put the units, centimeters, and this is also 4 centimeters. This line is equal to this line, and this line is equal to this line, going by the circle theorem. Constructing another radii or another radius, I have line OM as shown. I'm going to construct another radius, line OK. Using the first triangle, I have drawing a rough sketch. I have the first right angle triangle, M. I have the center O, and I have the point B as shown in the diagram. We've been given the radius to be 5 centimeters. So that remains the same. The line OM, the radius is 5 centimeters. I'm going to adjust that. That's 5 centimeters. Also, the distance BM or MB is 4 centimeters. I'm going to find the distance OB. Therefore, using the Pythagoras theorem, the line OM squared, which is the hypotenuse, equals the sum of square of the other two lines, that's MB squared plus OB squared. OM as given is 5 squared equals MB squared, that's 4 squared, plus OB squared. Making OB the subject of formula, I have OB squared equals 5 squared minus 4 squared. That will be 25 minus 16. 25 minus 16, that's 9. To find OB, I'm going to find the square root of both sides. Therefore, the line OB is equal to plus or minus 3. I'm taking 3 because we are talking about distance. We don't have negative distance, but positive distance. So putting that back in the diagram, I have OB to be 3 centimeters. Remember, the distance R, which is the value we are looking for, is the same as the distance BA. So because it's parallel, this is also R. Using the second triangle, I'm going to draw that out. I have the right angle to be at point A. I have the center at O. Putting in the value, I have OA, the distance OA to be R plus 3, as shown in the diagram. The distance OK is also the radius, which has been given as 5 centimeters. And the distance AK is 3 centimeters. To find R, I'm going to use the Pythagoras theorem, which states that OK squared is equal to AK squared plus OA squared. OK has been given as 5, so I have 5 squared equals AK squared, that's 3 squared, plus OA, that's R plus 3, all squared. Expanding the bracket and collecting like terms, I have 25 equals 9 plus R squared plus 3R plus 3R plus 9. Collecting like terms, I have 25 equals R squared plus 6r plus 18. Moving 25 to the other side to make it a quadratic equation, I have r squared plus 6r plus 18 minus 25 equals to 0. R squared plus 6r minus 7 equals to 0. Factorizing, I have r plus 7, r minus 1. Therefore, the value of r equals to minus 7, or r equals to 1. R minus 7, that's no solution. So therefore, the value of r is 1. Thanks for watching. Bye.